Solve the second derivative minus 10 times the first derivative plus 25y is equal to 25e to the 5x. This is type A times the second derivative plus b times the first derivative plus cy is equal to f of x. So the solution will consist of the complementary function plus the particular integral. So the complementary function, cf, we try y is equal to e to the mx. If we differentiate that again, we get me to the mx. Differentiating again for the second derivative, we get m squared e to the mx. Now we substitute this in to this one, which is equal to 0. So the same as here, but equal to 0 to get the complementary function. So you get m squared e to the mx minus 10me to the mx plus 25e to the mx is equal to 0. Common factor of e to the mx, and you're left with the auxiliary equation m squared minus 10m plus 25 is equal to 0. This is a perfect square. This cannot be negative, and it's always greater than 0, so we say that m squared minus 10m plus 25 is equal to 0. Auxiliary equation, perfect square, so it's going to give m minus 5, which gives m as 5 as a repeated root. Now, for repeated root, the complementary function is going to be y is equal to a plus bx e to the alpha x, where alpha will be 5. So in our case, y will be equal to a plus bx e to the 5x, where a and b are arbitrary constants. Now, for the particular integral, we have to be very, very careful here. We need to modify it. Right. Obviously, the thing we would like to try is k e to the 5x, but we can't use that because y is equal to a to the 5x is a solution of this. Also, we can't use kx e to the 5x in this case, because that's also a solution of this. We need to try, so note, if any term of the particular integral is a solution of the complementary function, then multiply the particular integral by x or x squared if required. So first you try x times it, and then you try x squared times it. So we've taken the basic function, that's a solution of this. Also, this is a solution of this because we've got bx e to the 5x. Therefore, we'll take the next one. So we're going to try y is equal to kx squared e to the 5x. So you just need to be wary about this when you're solving this type of differential equation. So if we differentiate this, you have to use the product rule. So we've got kx squared times the differential of e to the 5x, which is 5e to the 5x, plus e to the 5x times the differential kx squared, which is 2kx. Tidying that up a little bit, we get 5kx squared e to the 5k plus 2kx e to the 5k. The second derivative, so we need to differentiate this again. So what we've got here is 5 times this. So we're just going to write this down again with a 5 outside. That's why it's in green. And now we just differentiate this using the product rule. So I'm just going to take the 2k out this time and then do x times the differential of this, which is 5e to the 5x, plus e to the 5x times the differential of x, which is 1. Now expanding the brackets, we get 25kx squared e to the 5x plus 10kx e to the 5x. Expanding, that's 5 times 2. 2k times all this is going to give me 10kx e to the 5x, and 2k times this is going to give me 2k e to the 5x. I'm going to tidy this up here and have 25kx squared 5x plus 20kx e to the 5x plus 2k e to the 5x. Now what we've got to do is substitute that, this, and this into this differential equation. So if you want to get on to the next page of the video, you want to pause it, take note of that one for y, first derivative, second derivative. Substituting into the second derivative minus 10 times the first derivative plus 25y is equal to 25e to the 5x. The second derivative is that from the previous page, minus 10 times the first derivative, which was this, plus 25 times my value of y that I guessed has to be equal to 25e to the 5x. Right, so we'll just write this bit out again, and then we'll take minus 10 into this bracket here. So you get minus 50k x squared 5x, minus times the plus gives a minus 20k x e to the 5x, plus 25k x squared e to the 5x is equal to 25e to the 5x. Right, put those two together and cancel it out with that one. Okay, and then put that one, will cancel out with that one. And you're just left with 2k e to the 5x is equal to 25e to the 5x. So, equating coefficients, we're going to have 2k is equal to 25, which is going to give k is 25 over 2. And therefore the particular integral, it will be y is 25 over 2 x squared e to the 5x. The total solution is a complementary function plus the particular integral. So that's going to be y is equal to a plus bx e to the 5x plus 25 over 2 x squared e to the 5x is the total solution for that differential equation. Okay, so this has been a video where you had to actually modify the particular integral before trying it, and I hope you've understood, and I thank you very much for watching.